Recognising graphs. I do see a question come up now and again on recognising graphs. So we need to know the shapes of linear graphs, quadratic graphs, cubic graphs, and reciprocal graphs. Linear graphs. Linear graphs are in the form y equals mx plus c, where the highest power of x is just x to the power 1. You might have something like y equals 2x plus 4. So what do we need to look out for here? Well, the straight line graphs. The m gives you the gradient, and the 4 gives you the y-intercept. So here, this graph y equals 2x plus 4 would cut your y-axis at 4. You've got to also bear in mind, you might have a negative gradient. So negative gradient slopes downhill. And then for this graph here, the y-intercept to be -1, it would cut through your y-axis at -1. Okay, quadratic graphs. Quadratic graphs would have an equation with a x squared in, being the highest power. So it might have a x term in as well, but it's always the highest power you look at to decide if it's a linear, quadratic, or cubic. So a quadratic graph is a curve. Also useful in noting this +1 here would be your y-intercept. Because if I put in x as being 0, we'd have 1 left over. That's always useful when you're recognising graphs, looking at the y-intercept. So what would happen if we had a negative x squared? Our graph would be upside down. And again, your y-intercept here would be +1, 2. So it would cut through your y-axis at 1. Okay, cubic graphs. So cubic graphs would have the highest power x cubed. Might have an x squared term and an x term in it, but the highest power would be cube, and it would look something like this. What's my y-intercept? Always seems to be 1. It is 1 here. Right, I'm going to draw the next one so it's not, we'll give the equation so it's not 1. So you could have a negative x cubed graph, negative cubic graph. Right, what would that look like? It would be this way around. You've just got to kind of remember that, or you could sort of work it out anyway. It'd be flipping round. And your y-intercept here would be 3. That is where it would cross through your y-axis. And your reciprocal graphs. I'm just going to draw this on a grid. So y equals 1 over x. You might have y equals 7 over x. X would be your denominator in your fraction. That would look like this. Let's look at a negative reciprocal graph. So y equals -1 over x, or it could be -5 over x. If you think about it, there's our positive. Like we're just putting a minus in front of all our answers, so it would flip into this axis here. And then the same with this would flip in your x-axis and would go up here. That's sort of what you've got to recognise. So let's have a look at a question. We've got 9 graphs here. Right, write down the letter of the graph that could have the equation. Part 1, part 2, part 3. Okay, so let's look at all our graphs first. which one is a reciprocal, which one is a cubic, which one is a quadratic, which one's linear. I'm just going to put the letter here. So for this is reciprocal, quadratic, linear, quadratic, linear, reciprocal, cubic, linear, quadratic. So hopefully you can notice those yourself. So the first equation here is for a linear graph, y equals mx plus c. Positive gradient, so it's going to go like uphill from left to right. Now my y-intercept here is -2. So let's look at our linear graphs. This has got a negative gradient here, so it's definitely not that one. This has got a negative gradient here, but it's also not that one. H has a positive gradient, and yeah, it's feasible that that intercept could be -2, so this one is H. Okay, part 2, we've got a quadratic graph. It's a positive quadratic graph, so it can't be Q, because Q is a negative quadratic graph. Can't be B, sorry. Q is for the quadratic, so it could be D, and it could be I. Let's have a look at the y-intercept is -3. So if you look at I, your y-intercept's positive. So here it must be D. And then part 3 is your reciprocal graph. This is a positive reciprocal graph. So it has to be A, F is a negative.